In construction today, a major topic of conversation focuses around sustainability and how the building industry is impacting our environment. Construction alone accounts for over 50% of wood consumed annually in the United States. One positive initiative to counteract this is the development of engineered wood products such as LVLs, LSLs, and I-joists. These are products designed to replace traditional dimensional lumber that's used for light structural construction. Because of their makeup, engineered wood products are stronger pound for pound than traditional lumber and consume fewer raw materials. Their increased strength means less material required to build a structure. Well, what does that mean exactly? Let's take, for example, framing a floor system using 2x10 dimensional lumber. The floor has a footprint of 40 feet by 28 feet. The joists would need to be spaced at 16 inches on center across the footprint, and they would have to be separated with an intermediate support beam because they can't span 28 feet without support. What we're talking about is a total of 58 14-foot 2x10s in order to complete this floor system. The same floor system, framed with engineered I-joists, can be spaced at 24 inches on center and span the entire 28-foot depth of the footprint. This translates into only 19 joists needed to complete the entire footprint for this floor system. In addition to the material savings on the project, the rotational manufacturing process for engineered lumber is much more efficient than the sectional cutting process for dimensional lumber. Consequently, what that means is less waste for creating engineered lumber as compared to that of dimensional lumber. But what makes engineered lumber more efficient from an application perspective? Well, let's take a closer look at these three products so that we get a better understanding. LVLs, or laminated veneer lumber, utilize thin strips of wood, typically 1/10 of an inch to 1/8 of an inch in thickness. These veneers are sandwiched together with bonding adhesive, compressed under high pressure and temperature. Now, unlike plywood, these strips are aligned with their grain pattern in the same direction. This dramatically increases the board's tensile strength, allowing it to span greater distances and support larger loads. As you can imagine, this makes it very suitable for load-bearing beam applications, such as a girder beam for a floor system. Laminated strand lumber is a product similar to OSB, or oriented strand board. They both use very thin, wide strips of wood oriented together in layers and compressed under high heat and pressure. Unlike OSB, which is a sheet good product, laminated strand lumber is a framing member product typically used for small beam sections, such as headers over doors and windows. Because these beams can be manufactured to the thickness of the wall framing being used, there's no need for any on-site labor to sandwich some framing members together like you would have with dimensional lumber. This saves a tremendous amount of time in the field. The last item we're going to talk about today is an I-joist. It's probably the most common of the three products that we've looked at, and it gets its name from its two components when brought together create a cross-sectional form in the shape of an eye. So the first two components, the top and bottom chords of the member, are comprised of thin wood strips laminated together just like an LVL. In contrast, however, to an LVL, the veneer pattern is a horizontal orientation rather than a vertical orientation. This makes the cord very resistive to bending stresses. Now, to provide support against shear forces, the middle section between the top and bottom cord, or what's referred to as the web, is made up of oriented strand board, which, as we mentioned earlier, is made up of very thin, wider strands of lumber compressed together into a sheet, and that sheet is typically going to vary in thickness from 1/2 of an inch to 3/4 of an inch, depending on the load that it needs to carry. The net result is, when you combine veneer and strand lumber technology in this fashion, it produces a lighter weight floor and roof framing product with load carrying capabilities superior to that of dimensional lumber. Now, All three of these products typically are priced just above that of their dimensional lumber counterparts, making them somewhat less attractive from a direct cost perspective. However, once you factor in their increased labor and material efficiency, that oftentimes nets a cost benefit. And this doesn't even take into account their positive environmental impact. In sum, these represent just a few examples of a growing initiative among professionals in the built environment focusing on a shift from environmental irresponsibility to ecological prosperity.